Alright, last video ended up in a real cliffhanger with number 47. This is EOC review, number 47 through whenever I'm done with it. Alright, so again it says when filling the cylinder silos, the top is not filled. Okay, so these orange areas are not filled. However, if the silo has the bottom cone filled, the bottom, it is filled, right? So these orange parts are not filled on the top. If it has a bottom one, it is filled. 3 different silos are shown in the image, right? So the only bottom part here is shown is this orange part, and that orange part is represented here, okay? In silo 1 and 3, so 1 and 3, the top and bottom cones are congruent. So 1 doesn't have a bottom cone, and 3 does have a bottom cone. How much more grain could silo 3 and 1 could silo 3 have than 1? So these ones here, 1 and 3, the pink parts are congruent, and number 3 holds more because of this cone. All right, so this pink area is this one. It's a cylinder. So what is the pink part? Okay, so the pink area is going to be pi r squared times the height. So pi here, the radius is, oh, it's not pink, is 2.4 meters. Radius of the pink is equals 2.4 meters divided by 2 is 1.2 meters. Okay, and then the height of both of these, the height equals 1.5 meters. So plug that in there. The volume is going to be equal to pi times 1.5 meters squared times, oh no, that's 1.2 meters squared. Almost got my height and radius mixed up. 1.2 meters squared times 1.5 meters. Right, so that's going to end up with meters squared in meters. Meter is right here. So it's going to be 1.2 squared times 1.5 equals times, I'll keep it in terms of pi. Okay, so it's going to be equals 2.16 pi meters cubed, because this is a 1, right? This is a 1 meter, right? So meters squared plus meters is meters cubed. Okay, now this one is the same radius. Okay, the same radius, right? The radius for this is 1.2, and then for here, it's a 1 meter height. Right? They're a congruent triangle, so the height equals 1 meter. Right? So the volume of these cones here equals pi times the radius squared, which is 1.2 meters squared, times 1 meter, right? Put the meter in there just to make sure it's divided by 3. Okay, so we're gonna leave this one in terms of pi 2 because we're gonna how much more grain. So when we're gonna divide one by the other, and the pi will just cancel out, and that'll be nice and neat math. Okay, so anyway, you're gonna do 1.2 squared times 1 equals divided by 3 equals, so this is gonna be equals 0.48 meters cubed, right? So this volume 2, or silo 2, is going to hold, remember, as it says up here, the top cone is not filled, right? So silo 1 is going to be holding, this is 2, oops, I forgot the pi down here. How could I forget the pi? 0.3 pi meters cubed. Okay, so this holds 2.16 pi meters cubed, and plus the 0.4 pi 0.8 meters cubed, for a grand total of plus 2.16. So for a grand total of, we'll just make it purple, 2.64 pi meters cubed in number 3. And then this one just holds 2.16 pi meters cubed. All right, so how much more does it hold? Well, how much more grain can silo? Okay, so we're going to do 2.64 divided by 2.16. The pi's would cancel out, right? So this one holds 1.2 times, or 20% more. It's 1.2 times is 20% more, because if it's 100% of it, it's 100%, right? The 0.2 is actually 22%. Actually 22%. Technically, it's 22% more. 22% more. Okay. So that is that one there. Okay. So there is that. Okay. So let's see what happens if we did it in pi. So we did 2.64 times pi equals 2.64 times pi equals, and we're going to divide that by 2.16 times pi equals, yeah, it didn't work out, 2.16, let's just round, I guess, 2.64 times pi equals 8.29 divided by 2.16 times pi, which is 6.79. Right, these are meters cubes, cubed meters cubed. Right, those are just regular things without pi. So 8.29 divided by 6.79, and you see it's still 1.22. Okay, or you could flip it, and it's 81%, 82%. This is 82% of that, so it's 82% more. Okay, so that is that one. All right, part B says if 80%, or if silo 1 has 80% the diameter of silo 2. All right, so they're being a little tricky here. All right, so we have to say this thing is skinnier than this one. I don't know why they just didn't have you like compare the two, but so 80% the diameter. So we got to take silo 1, and let's just change the picture. So 8% of 2.4, so 0.8, so that's 80% in decimal form. Right, if you didn't know how to figure that out, you go 80 divided by 100 is 0.8. Okay, that's 80%. Times, remember, of is mathematical, or time multiplication is the mathematical form of times 2.4. That means that the new diameter would be 1.94. Do that again just to be sure. 2.8 times 2.4. Yep, 1.92. Man, that's why I was sure. 1.92. 1.92. Okay, so that's our new diameter. And therefore, our new radius is going to be divided by 2. Okay, so it's going to be 0.96. 0.96. All right, so again, not full. Doesn't have anything into it, not taken into consideration. Okay, so our new volume of this is going to be pi r squared times the height which is 0.96 meters. We're going to square that times 1.5 meters times pi, and that's going to be squared that times 1.5. That's going to be let's multiply that by pi, times pi. That's going to be approximately 4.34 meters cubed. Okay. Is the capacity of 80% capacity of silo? Okay. All right. So now we got what is the capacity of silo 2? We never calculated that ever yet. So this one here, silo 2, radius is 1.5. All right, because that divided by 2 is 1.5. Right. So this is going to be radius squared is 1.5 meters squared times the height of 3.5 meters times pi equals, so 1.5 squared times 3.5, that gives us our meters cubed, times pi equals 24.74 meters cubed, and that is not the capacity. Right, so silo 1 is 4.34 meters cubed divided by 24.74 meters cubed. Right, so 4.34 divided by 24.74 is, it's 20%. 20% the capacity. Not 80% the capacity. It's 80%. It's 20% the capacity. Okay. So there you go. That's how you figure that stuff out. Okay. All right. We're going to be doing some stuff with surface area here. So we're painting some pedestals. These are the 3 pedestals. And we know that 1 gallon of paint, 1 gallon covers 400 foot squared. Okay, that's something that is going to be universal for all these 3 things. All right, and these are the 3 pedestals. Okay, so how many gallons will they need to cover at least 4 of each type of pedestals? Okay, so we got 4 of each of these. So we got to figure out the bases are not going to be covered, so we don't need the base, but everything else will be. So we need to calculate everything except for what I colored there. All right, so we're going to calculate each one of these, multiply it by 4, and then figure out how much we need based upon that. Okay, we got at least 4 each of each one of these. All right, so let's do the squares, or the cube. Excuse me, the cube. The cube. Okay, the area of the cube is going to be the top plus 4 sides. Okay, that's the surface area of the cube that we need to paint. Okay, and then we have the cylinder. It's going to be the top plus the side. And then the triangular prism is going to be 3 sides and the top. Okay, so let's figure that out. For now, well, I got classes starting to come in, so start thinking about that. Okay, and then we'll cover that one in the next video.